Microphone working? You guys hear me? All right, we'll see how this goes, because I had some windows set up which have been blown away because I had to restart the computer, but let's see how we go. All right, so today, I'm going to make this quick because it's definitely beer o'clock. We're going to talk about source code analysis. And the idea for the talk is really to just be a random collection of tips. And there's a really good chance that most people, some collection of, will know a lot of these tips already. You might have better tips. And so hopefully this provokes some tool and tip cross-pollination over beers later on. So the talk is called Audit at the Speed of Thought. And mainly because I thought it sounded cool. But the title encapsulates the idea that it's really good to spend time researching and establishing workflows that make you faster at performing your role as an auditor in an offensive security context. So in the talk, I'm going to talk about a bunch of different tools, but rather than give like a full explanation of how to set up some of the tools and the workflows, what I hope will be better is that I'll give an explanation of the intended effect, and then at the bottom of the slide, I'll put like a little index of keywords or a phrase that you can Google or ask the robot so that you can set it up at home. And so that might look something like this, just for reference. Okay. So the main through line of this talk is, if we have access to the source code of a target, it's incumbent upon us to leverage that access to the greatest extent possible. There are probably infinite ways that you can do this. And I'm really hoping to hear from people later over the beers about their own tips and tricks, because I feel like everybody does this in different ways. But I'm going to cover some of the things that I think are kind of foundational in this respect. And the idea is for hopefully you to come away with some new ideas, at least as far as how aggressive you should be when leveraging the advantage you get by having access to source code of a project. So a disclaimer that the examples in the talk are very C and C++ centric, but the principles should extend to any language or project if you have full access to the source and build system. All right. So reading code, what's it all about? Unless you're a mad genius and you can hold infinite state and context in your mind, then when you're auditing a project, you have to be able to read code in a non-linear fashion. So deeper bugs that involve an error in the implementation of some mechanism that leads to a buggy state in the target, for instance, are almost always going to require you to follow control flow through definitions of functions, to understand the definitions of types that are used and operated on. And all of this requires you to perform actions on the code. So for instance, moving your editor to the position of a project where a particular definition lives. And that's the sort of key here, is that you need to be able to perform actions on the code that you're reading. And these actions, the thesis here is that these actions can and should be done as fast as it takes to think that you would want to perform that action. So the worst way that you could go about something like this is if you're reading some code and you find a function that you'd like to know the definition of, and then leaving your editor to grep the code to find where it's defined and then manually browsing to that definition is really slow. And it can be done much better than that. The most common way that this is probably approached and done by most people is to use like VS Code with a default C and C++ IntelliSense plugin, which is totally okay depending on the complexity of the project. But in my experience, there are some shortfalls and it fails in some key ways that are really annoying. And it can also fail transparently, which is extra annoying because when you're auditing, it's really, like, completeness is very important. So if you're looking for references to a particular symbol within a project and it transparently omits some when you're trying to enumerate them, then that's really annoying because one of the ones that it misses might be critical to your audit. Probably a skill issue on my part as far as configuring VS Code's IntelliSense properly, but we'll look at why I think there are better alternatives. And in my opinion, the best with regards to C++, but also in general, is using language servers. And for C and C++, the default, or like industry standard language server is ClangD. So this standard and best way, in my opinion, and the most powerful way to enable code actions in almost any editor actually is with these language servers. And so they're a standalone process that provides a standard interface for any editor to send commands and queries, and they'll be returned with the information necessary to perform an action that you might want to perform on the code. So where does ClangD win over some defaults like IntelliSense? So anecdotally, and probably with enough configuration, they're quite similar, but anecdotally out of the box, I find that ClangD just feels faster. And I think that this is because ClangD front loads the indexing of the code base that it's operating on. And so IntelliSense manages an index of the code, but I think that it evaluates it lazily so that each time you find a new reference, it just feels like slow because it has to do that indexing as you're wanting to find that reference. And then if you're operating on a really huge code base and often looking at new symbols and different types and wanting to find different definitions and references, it just feels slow all the time. Additionally, in the sort of default configuration that it operates under, IntelliSense doesn't have an awareness of how a project has been built. And so if you have like compile time flags that have been used that conditionally compile in some things but not others, IntelliSense doesn't know that, and so it has to kind of include two definitions. Say if you had a thing that is defined conditionally based on a compile time flag, it has to list both, which kind of means that you get a whole bunch of extra information. It muddies the water and it's annoying. ClangD also should work in like any editor. You can use it in VS Code, you can use it in Sublime, you can use it in Vim. It can be used everywhere, same as any language server really. So for ClangD specifically, for a given language or project, as I mentioned before, the language server might need to use some artifact to understand how the project was built. And the example that I mentioned earlier is that we might have some part of the code that's only included conditional on some compilation flag. And the way that ClangD does this is with a file, compile commands JSON. And so how do we get this file? There's a few ways. For C and C++ specifically, we need compile commands JSON, and we can create it with like a utility like bear that just wraps the entire build system. That's a pretty nice and straightforward way because you can just invoke any make or build command for a project wrapped in bear, and it'll observe the compilation instructions that are taking place and then output this file for you. But then really big projects might also have their own set of scripts to generate that file. So for instance, V8, the V8 project and Chromium have a sort of generate compdb Python script that generates that file, and often big projects will have their own artifact. All right, so now's my intention to play around in V8 a little bit. Let's see how that goes. I don't know how it's going to go. Giving it up on the big screen. All right. How legible is this? Thumbs up. All right. So I've got a specific function up because it's a function that we're going to talk about more. But there's actually a bug here. So this is an old revision of V8. And there's a bug in this function. And it's a little subtle and hard to figure out without some familiarity with the V8 codebase. So we're going to walk through it. And then we'll look at why it's really handy to be able to browse through a codebase like this really quickly in order to be able to do root cause analysis on an issue like this or find it in the first place. So the issue here is, first of all, this templated class instantiation being used to declare this variable deop data. The purpose of this is to create a reference that is not observable by the garbage collector, which is broadly a mechanism that manages memory in the C++ runtime in V8. And the point of that is that it can allocate free, move memory around. If a reference is invisible to it or not observable to it, then we really need to make sure that garbage collection doesn't occur before that variable is then later accessed. For instance, down here, we see that same variable being dereferenced down here. And so you'll probably guess that the mistake is that somewhere in here, there's a function that can end up triggering garbage collection in some way. All right, so the answer is that this function can, but the way that it can is like really obscure. And sorry, this is a little weird to do when I'm creating it, but so we have source position information, then its constructor, and then a function get position info. This eventually calls into this function. And init line is internal. And we get a hint here, like we've got an array that's being returned by a function, which is suspicious because we're in a context where garbage collection shouldn't be able to occur. So here we can see like a new object is being instantiated, which has the potential to trigger garbage collection. And the point of this is not really the bug itself, but it's that we can really quickly and effortlessly browse through the code base using preferably like shortcuts on the keyboard that make it really, really quick to go through the code base without having to really think about it. The main point that I'm making here is that it's really important to avoid the pitfall of, or that if you're finding when you're browsing a code base that there are actions that you're performing regularly, and really those are almost predominantly going to be go to definition and find references, then, so for instance, it's going to look weird because but being able to find all the references to a particular symbol instantly is like really important. If you're finding in your workflow that it takes you longer than doing it instantly, then it's really worth looking into, can I make this like faster? Like this is something that I'm doing all the time, and I promise that it'll be really valuable. All right. That is exited presentation mode. Cool. Nice. All right. So, takeaways. Basically what I just said. Make sure you can do everything really quickly. Push yourself to learn like new actions that you can perform on codes. That's like that unknown unknowns. Like if there are things you don't know how, you don't know what you don't know how to do, like do some research to be like, what actually can you do? And then maybe like define custom actions that are backed by custom tooling as well. All right. The next installment in the grep is bad saga is a semantic code search. So what does semantic code search mean? So although like the text of code when you're reading it is linear and can be searched through linearly with something like grep, for instance, there are certain tools that let you leverage like an appropriate interpretation of that code within some intermediate representation. So why would you want to do this? Started off writing here that the reason for this is that there are some bugs that you just can't grep, but then I realized that it might technically not be true because maybe you technically can represent every bug as a regular expression, but I'm sure I was worried if someone would put their hand up and be like, actually. But so what I'll say is that it's infeasible to characterize some bugs with a regular expression in a general way. And so it's really handy to have a way to search over some intermediate representation of code. So here's an example. So there's a bug here, which is that we're using the return value of snprintf to index into a buffer. And the issue is that snprintf might return more than, it can return how many bytes would have been printed before truncation, which means that if we use that return value as an index into a buffer of that truncating size, it might go out of bounds. And so this is the sort of thing that would be quite tricky to grep for in a general sense because, you probably could, but it'd be annoying and tricky. So a tool that we could use to search for bugs like this across a code base in a general case is a tool called Wegley. And this is what a query in Wegley would look like and what the returned result would be. So this query sort of says we'd like to look for calls to literally the function snprintf, but then we're sort of symbolizing the length or the return value of that. And we're symbolizing the buffer argument that's being passed as the first argument and an argument to the size of as the second argument. And then we're saying an arbitrary number of statements later within the same scope, use that length symbol as an index into buffer plus some wildcard value. And we say it matches against the second of those indexes, but not the first. Now that's why I think this is a nice example, because it highlights a limitation of the tool, which is that it is a little bit rigid in how general you can be with what you're specifying. And although it is matching over like the abstract syntax tree of the code, it is still somewhat literal in some sense when it comes to matching against certain structures. So, but really, really cool tool, and definitely one worth looking into when you have an idea about a bug pattern that you might. If you find a bug, for instance, and you'd like to look for variants of it across the code base, then rather than grepping for all calls to strcopy, you might try to formalize it a bit further to increase your signal to noise ratio on that kind of thing.
You do need to include GitHub when you search for it, because otherwise you end up with photos of
Yes. Wegley GitHub. Yes.
Ask me how I know.
Okay. So what if the pattern that we're looking for is more subtle or complicated and requires us to be able to capture a more complicated structure in the search query? So, for instance, we may also want to perform that sort of query against other languages as well. Wegley is sort of specific to C and C++, I think. So in the case where we might want to perform much more sophisticated queries across different languages, then we'd probably go for a tool like CodeQL. So CodeQL is super powerful. It effectively lets you compile a code base into a queryable database, and then uses a custom query language to specify and find patterns. It's really heavyweight with a lot of initial time needed to be spent learning the query language, for instance, and also compiling the databases takes a really long time. But the documentation is really good. And I'd also suggest that like the exercise of taking a bug and then figuring out how to express that bug in a query language is a really valuable exercise in terms of like forcing yourself to really understand what's going wrong when you have a particular software issue. So take a look back at the VX code that we looked at before. So this is the same bug. And we're going to think about how to write a query like for this sort of issue in CodeQL. So we kind of have three elements, really. We have a variable declaration that has a particular templated type, that tag type. Then somewhere after that, we have any call that eventually leads to allocation, because allocation can trigger garbage collection. And then later, we have that original variable being dereferenced in some way. And the idea is that if garbage collection occurred, then by that time, because the variable is invisible to the garbage collector, it'll be a dangling reference that points to freed memory or something else like that. So a CodeQL query that encodes those three conditions looks like this. So let's walk through this, and because it's a little bit much, but once we walk through it, it actually should make quite a lot of sense. So being a query language, we can really think about CodeQL a lot in a lot of the same ways that we might think about SQL. So we're querying a database of facts effectively. And so how do we read this? So we'll start with the from statement. And we're effectively saying, like, from this code base of facts about the code, we'd like to select all variables, all functions, all calls, and all variable accesses. And then we're going to use a set of like predicates to restrict the ones that are actually being returned. So the first is tagged local. So we've defined a predicate at the top that basically restricts the variables to those that have been declared with that tagged template specialization. Then we're saying that we want functions that have the same enclosing function as the variable that was declared. So that's what that get enclosing element. So functions, we're selecting all functions, but function has to be the enclosing, we're defining a start function, which is the enclosing function of our declaration. So then we're saying, okay, then we want a function call which is literally just allocate raw, so an allocation that might trigger garbage collection. And then we've got a reaches predicate that says some later call site within the program should be able to reach allocate raw. And so we've got this reaches which defines this transitive closure to indicate that the call could be at any depth. And then we define a later use of that variable, and the get location, get start line compared to get location, get start line is just specifying the relative order that they need to be, because it's important that we have the variable declaration, then it's, or instantiation rather, then garbage collection, then the access. So is there anything wrong with this? I'll give you a hint. It will find a lot of false positives. I did have the results that it returns. It returns a lot of results. It does find the bug, but it finds a lot of other stuff that aren't bugs. So what's an issue with this? There are some structures that it doesn't capture that aren't bugs. So for instance, these set of conditions that were specified could be true, but also you could have variable instantiation, then garbage collection, followed by an unconditional return from that function. So the variable is never dereferenced and it's never used. And that's not a bug. And so I guess I left it this simple because I'm lazy, but also because I think it's good to also highlight that getting the exact query right forces you to really understand everything. And sometimes, I guess the tool is also very useful in sort of when you're not able to fully capture the structure of a bug, in giving you a whole bunch of leads that you can then look through manually. So it is quite a useful tool for exploring the code base and pointing you in the right directions to be used in conjunction with manual audit. But of course, if you're able to encode bugs really, really well, then it's a really good VR tool. It's a good CI/CD thing. It's overall really impressive and really cool.
The issue with this one was because you didn't limit when it should stop looking for the target. So instead of using the same block of function where the allocation was assigned there, so you could quick find, just didn't put a limit, and then the thing started looking for all those patterns of the code to return a lot of false positives.
I haven't quite understood the question. So do you mean that the call depth could be as deep as possible, or?
The tag thing is that you say, okay, so this tells no garbage collector, right? And then you look, okay, I want to find this, and just after somewhere where allocation is happening, so it could.
Well, the get enclosing element limits us to the scope of the declaration of that function. So we are limited to that scope. And then in terms of call depth, doesn't matter how deep the call is. And in fact, I think that the ability to really quickly find all of the places from which like a particular function can get called is one of the most powerful things about this. Like in general, even just that feature makes it worth learning to use. Like if you sort of go, this is an interesting function, I wonder where it can get called from. And you might have sometimes the Chrome and V8 code base is ridiculous. Like you might have, 30 function calls nested to kind of, because they all sort of get inlined and so on.
A hint to help with triage, how you can triage that data. So
I guess, yeah, right, better query. You just kind of have to, if there's something, because like this returns like thousands of results. And so when I first sort of having a look at this, I was like, oh wow, this pattern's everywhere. And then you sort of think, okay, no, that you can't actually reach that because of this other condition where it's like the one that I mentioned whereby a very common pattern was to see this except the garbage collection happened because, the allocating behavior happened because of some like pattern that would occur in like an exit stub that was always before a return. So it's like, it's fine if we allocate this object right before we return because we're never referencing this thing again. And Chrome internally have some static analysis tooling that they use to uncover this kind of thing. But for some reason it missed that one. But it was patched a few months ago. All right, very nearly done. So another really great advantage that we get when we have access to the source code of a target is the degree to which you get to instrument it for the sake of detecting bugs during manual and automated testing. So if you're performing automated testing such as fuzzing, two core principles that you want to exercise as much of the code as possible, or at least make sure that you're exercising specific code that you're interested in. And then you also want to make sure that you have a really high chance of catching bugs if something goes wrong. So in modern C and C++ tool chains, they provide a lot of really cool tooling to do both of those things. So one of these is address sanitizer. It's effectively a library that hooks common memory operations like allocating and freeing and accessing, etc. And it will crash in the case that would not normally crash without address sanitizer. So for instance, you can think of like a 1 byte overflow into a contiguous memory region that is also writable that wouldn't cause a crash in a normal program in Linux, but ASAN will catch that, which is really handy for fuzzing. And the LLVM project also gives you a lot of ways to instrument code to determine how well covered it is by testing. So sanitizer coverage allows you to, for example, insert callbacks to specific parts of your program to programmatically perform some action, like set a bit in a bitmap or something like that. So I do have an example coverage report. And in general, for like automated testing, it's just open it up. It's really useful and important to generate this kind of report because you can say on a line-by-line basis, so I'll just nope. Cool. So this is what it looks like for like a fuzzing run on V8. So getting to see like for every file the number of functions that are covered, the number of lines, the number of regions, and the number of branches, where there is some subtle semantic difference between branches and regions that I can't recall, is super handy because you can say, for instance, if we go to some function here, you might find some functions that aren't being touched at all, or that, or within a particular function. Here we can sort of go and say, okay, which, and it'll be able to provide you with like line counts of coverage, hit counts per line of source code to sort of understand like how well your fuzzer is touching certain things. We can see like these conditions are never hit, for instance. These lines never get hit.
What was the entry point for the fuzzing? Like is it a particular function, or is it scanning the whole code base?
Ask that again, sorry.
What's the entry point for the fuzzing? Like you starting from one function and
So this is for the V8 JavaScript engine that's just executing like a JavaScript file. So it would be starting from its main function, I guess, and then parsing the JavaScript file and then potentially compiling it with a JIT and stuff. So
So it's like it's code coverage of the C++ code base on the basis of the execution of the JavaScript file.
So in this particular case, it's on the basis of a corpus of files, each of which is executed once. Yep, yep, good question. All right. That's basically it. Any questions? I think it's beer o'clock. I'm very thirsty personally. Yes?
You mentioned the amount of time code QL takes.
Yeah.
Is it on the order of minutes or hours or days?
So to compile the database, hours depends on the size of the project, and it's also like really memory intensive. So if you're building like a big project, you usually would need to restrict the number of like cores you're building on so that the concurrency doesn't eat all your RAM and stuff. The queries usually. So the queries, you do need to, I guess, spend some time to understand how optimized your query is, because some queries might never end if they're sort of really unoptimized, and then a good query can do really impressive stuff really quickly, and usually only like a few minutes, even for a huge code base like V8. All right. Yes?
When I'm investigating something, I find that, like you said, I run into a lot of false positives. I'm jumping like in and out definitions. I have like a gazillion like buffers open.
Mm-hmm.
Like, do you have opinions or a system on like how you don't get lost with what you're doing, or like bookmarking?
Good question. I guess it depends on the specific case. Like when you say a false positive, I think that it speaks to like why it's important for like from a technology perspective for your system to be thorough in the sense that it returns you all of the results that are there. So for example, and the reason for that is that if you're doing an audit, you do need to be able to, at a certain point for a certain thing, say, I have looked at this now, I don't need to look at it again. That applies to a certain degree, because of course if you look at something and understand it, it might become interesting and important once you've looked at something else. I think that in general, you might say that if you're starting an audit and you're looking at trying to find bugs in something, you might start by for instance, picking a part of the code and then trying to understand it at a high level. And in that context, you're probably not going to sort of say, I'm not going to look at this again. You might just be jumping all around the place, and how you actually go about building a mental model of what you're looking at, will just maybe necessitate jumping all over the place. And then later, once you've got kind of that mental model, either your approach is going to be based on some ideas that are based on your understanding of the structure of the code, or you might be looking for more implementation style bugs which do necessitate just a kind of linear traversal through the code. So I think in general, taking lots of notes, trying to consciously build an accurate mental model of the thing that you're looking at are two ways to do that. But I think it's a solved problem though. Yeah. Yep.
Based on your approach that you have in your brain while you are looking at reverse engineering or fuzzing, how efficient you have seen AI while you giving instructions in order to act on the pointers that are there in your brain?
Yeah, it's a really good question. So I originally had some like content that was like going to be basically like asking AI to do stuff, but because I So if your question broadly is just to summarize, how good is AI at finding bugs? Impressively good, which isn't to say it is good, it's just very impressive. Like I'm like, I'm like very skeptical about AI, but it's sometimes scarily good. And I will just sort of like give you an example of like just something that it can do, which is kind of cool.
Do you have an opinion on like OpenAI's aardvark thing?
Yeah, not yet. I haven't really seen that. They haven't really posted anything that it's done. They claim that it's found CVEs. I guess it'd be interesting to look at what the bugs are that it is supposed to have found.
Have you tried to use the help to write code QL with AI? Does it
CodeQL. So good question. It's almost useful, but it just hallucinates a lot, which is really annoying. So I've been trying to figure out a way to expose like the documentation to it so that it can just, because I'd love to just be able to say natural language, like find this kind of thing, or have it look at a bug and yeah, it'd be awesome, but it's just not quite good at it yet. But it's almost good.
Have you tried to, for instance, give a solid database of valid types of queries to it and say, hey, can use this kind of knowledge that's here in this database?
Not yet. I have not done that, but I think that's a good idea. Yeah, but you have to have like a company to get access to the beta and stuff, so that's annoying. But so to answer your question, like, so some of the things that I've tried with it are, so like Codex was able to like one-shot writing like its own MCP server to expose like coverage information. So then you ask it like, oh, I would like you to write test cases that cover this part of the code, and then it can do that like really surprisingly well. So maybe I can do an example of this. So this will probably take ages, but it's like, I'll see if I can open up the ones that it came up with, because it comes up with like pretty insanely good like.
For instance, if you ask the AI to do that search that you did.
So just to show you, like these are like samples that it wrote just using like, just sort of go, oh, like write your own samples, and then, so let's just see what it's doing. So this is using like a coverage MCP server to kind of like write a sample, and then it runs D8 and it gets that like coverage report, but in JSON instead of the HTML format. And then like when I think the key is like if you give it like good tools and like a way to really focus its context, it can do like super cool and impressive stuff. And like maybe, but that's yeah, which is awesome, because you can use it to find bugs in V8. But yes, I definitely sit in the camp of like they're not thinking, they're not doing reasoning, but the fact that like, you know, effectively what amounts to like, you know, it drawing a path through like a vector space of tokens or whatever, that it's able to, I don't know, like use this and then come up with like
it's not completely useless.
no, definitely not. I'm really interested to see what the Aardvark stuff is like, but like, you know, kind of having this development loop of just like make it write its own MCP server to do an impressive, like difficult task that it can't really achieve with text, then like leverage that to like do research work. It at the very least gives you like good leads in security research. Yeah, I think it's not quite at the point where it's just finding all of the bugs. And certainly probably these tools are writing enough software so that the bugs aren't going to run out. But
I found that's pretty good to find pattern matching. Like when you explain to it the pattern that you want and
yeah,
look for that.
yeah.
It's pretty good.
But I like Codex is awesome. Like I do use it a lot. It's pretty sometimes just it's frustratingly bad at some things like CodeQL. I think like I did try, for instance, like to give it the documentation and say here the doco's here, read the doco, and then it like just distill. It'll go, oh here, try this, and you run it. It's like hallucinated a bunch of like stuff, and it's a bit annoying. But like if you use it in conjunction with the documentation, just like fix what it got wrong, it's useful for sure. Versus kind of like starting from scratch with CodeQL is pretty like daunting to kind of like learn the query language from scratch. So
It's good for testing your assumptions as well if it just tells you some absolute bullshit.
yeah.
Oh, okay.
Yeah. There you go. It's kind of like writing JavaScript and then
So this is like a samples to fuzz, right?
yeah, so I basically just tell it like come up with stuff yourself and then you can test and see how much coverage it generates for different files, and it's like I want you to focus on these files, so like if you get it wrong then come up with something else, test it again and just go in a big loop and like yeah, it's pretty impressive. I think we're definitely at the very beginning of people figuring out how to do insanely impressive stuff with this. And like Google has like a project, Google Big Sleep, which is finding impressive bugs. So they actually have proven that they can find bugs. Like Aardvark probably will be impressive just based on how well GPT stuff performs in general. But right, that's it. Yeah.